Welcome. Let's discuss how we can find inverse functions with domain restrictions. Let's start by considering the function of f of x as x squared plus 2. And what we want to figure out is, can the inverse be considered a function? So let's start by defining the function for the inverse. We're going to get the function of f of x, and instead of writing f of x, I'm going to rewrite it as y. And now to define the inverse function, let's apply the property for inverse functions. Let's switch the location for the variables of x's and y. Whenever there's a y, let's switch it with an x. And whenever there's an x, let's switch it with a y. By doing this, we're switching the domain and the range of our inverse function, which is a property for inverse function. So now that we have given this property, now let's solve for the new y, which we can find it here. Let's start by subtracting 2 to both sides. And to get rid of the second exponent, let's take the square root on both sides. But whenever we take the square root and solving for a variable, we need to consider the positive and the negative outcome. So we will write it as plus or minus the square root of x minus 2. So even though we have defined this function, let's use the correct notation. If the function was called f of x, then the inverse will be f negative 1 of x. And it will be defined with the function that we found previously. So now that we have found the inverse, now let's see, can this inverse be considered a function? Let's graph this function and let's see its behavior. So here at the bottom, now we have the graph of the inverse function of plus minus square root of x minus 2. And the first thing that I notice is that this function does not pass the vertical line test. Notice that if we draw a vertical line on this function, we are intersecting the graph at two different locations. Therefore, the inverse cannot be classified as a function. But now let's go one step further. Let's try to think about, is there any way that we can make the inverse a function? In other words, is there any way for us to make the inverse pass the vertical line test? Let's take a look at the following. So here we have the original function that we were given, x squared plus 2, shown in the graph on red. And we also have the inverse function that we found previously, shown in the graph of blue. And just a reminder that we have shown previously that the inverse function failed the vertical line test. Therefore, it's not a function. So how can we make the inverse be considered a function? We can place restrictions on the domain of the original function, f of x. So notice that in the original function, which is shown in red, that function does not pass the horizontal line test, which is an indicator that the inverse will not pass the vertical line test. So now we want to think about restrictions that we can place on the original function in red that will make it pass the horizontal line test, and that will make the inverse pass the vertical line test. And this is true because remember that between a function and an inverse, the domain and the range, they switch locations. One way to make the red function pass the horizontal line test is to just consider the x values on the left-hand side of the vertex of this parabola. Because notice that if we do this and we ignore the x values on the right-hand side of the red function, let me cover them in white. Now, if we draw a horizontal line, notice that we're only intersecting our function in one location, not in two as we originally had it. And one way to make this happen is to only consider the x values on the left-hand side of 0. So that is a restriction that we should consider. We can place a restriction on the domain only considering the values on the left-hand side of 0. X is less than or equal to 0. But how does that affect the inverse function? Well, remembering that the domain and the range, they switch locations. If the original function had a restriction on the domain, then that same restriction will be on the range of the inverse. So we will only consider those locations where the y value is less than 0, which we have it here. So therefore, we will ignore all those y values which are greater than 0. So let's cover them up. And if we only consider this section, notice that now we will pass the vertical line test. We will only intersect the inverse function at one location. But this is not the only restriction that we can consider to make the inverse a function. We could also consider the restriction where we only consider those x values on the right-hand side of the vertex of the original function. We can consider those x values which are greater than 0. So let's cover the section that we are ignoring. And I notice that the original function now will pass the horizontal line test. But how is this reflected on the inverse function? Well, knowing that the domain and the range, they switch location. If now we are considering the restriction where x's are greater than 0 on the domain, then in the inverse, we will consider those y's which are greater than 0, which is what we're going to highlight in yellow. So let's cover what we are ignoring. And notice that if we do this, and we only consider those y values which are greater than 0, now my inverse function will pass the vertical line test. Then we can claim that the inverse now can be considered a function. So to summarize, if the inverse does not pass the vertical line test, think of restrictions that you can place on the original that will make it pass the horizontal line test. Because when your original function passes the horizontal line test, then the inverse function will pass the vertical line test, and then we can claim that the inverse is a function. Hello, if you would like to continue learning about mathematics, you can check out the videos on the left.